plus.
But how did you get like 10 plus 3? I mean 10 plus 20 plus 3.
Because he did 7 plus 30.
If you are not done at your table, please raise your hands. All right.
Stop touching my stuff.
Okay, so let's come back together on part A. So, did Juno get the correct answer? Yes? Okay. So what are some possible ways she could do this? Over here. I'm sorry? Okay, how'd you change the order?
We did 24 minus 4, which is 20, and then 3 plus 7 is 10, so 20 plus 10 is 30.
All right. Does everybody see how they did that? All right, and they used the properties of commutativity and associativity to make their arithmetic easier. All right. What's another way somebody did it? Avery.
I think we did kind of the same thing, but we did 27 minus 4 plus 7.
Okay. So 27.
4 is
Oh, plus 3. Backwards, plus 3. Is that the order, or do I have it backwards?
no, well, 24 plus 3 is
Oh, 24. All right. Okay, here we go. 24, 27. I cannot get my numbers right here. All right,
27
here it
minus
goes. Okay, thank you. Plus 7, plus 3.
No, so
All right, who's on first? What's on second? All right,
okay, first we
I'm gonna just rewrite it. Let's try it one at a time for me.
we combined 24 and 3 to be 27. And then we subtracted 4
Okay,
and then
plus 7, I don't know if you can see that, equals 30. All right, so that's a slightly different way of writing the terms. So, all right, everybody on board with that?
Yeah.
All right, good deal. All right, so let's go to part B of that question, about 2 minutes on that question.
Didn't they do part B?
Pardon me? Oh, did we?
Yeah, they already did part B.
Oh, okay. Sorry about that. It's a little different. So, but the idea is to get 20 and 10 to simplify the arithmetic, which is basically what Avery did and the other table did. All right, so let's go to problem 3-113. And so go ahead and read through that problem and then work on part A, please. So 3-113.
Did you end up getting your homework from Mr. No? So why don't you come back? Just sit right here. That's all right. But yeah, when you come in here, you need to not just sit and ask any questions. I've already done
I didn't
We got to it a little later. I left it to last. Do you want to go ahead and get your...
We use commutativity to change the expression.
Anyway,
How much do you want this?
it's not really math. It isn't.
Social property, additional items. Instead of adding from left to right, adding to there would be like put the 24 and the negative 4 together.
No way, it doesn't work.
So,
So it's only
does
addition.
it work for operations? In other words, multiplication, division, subtraction be done in order? So maybe think of 2 examples, you guys, like do something that has addition and subtraction in it. Can you switch it around? Okay.
You can do 8 times 7.
Okay, can you, Thomas, come up with maybe 2 ways, 2 different things that show that?
All right, let's bring it back together.
Okay. What about the right thing? You can't.
All right, Tabus. Tavius? Oh, I'm sorry. All right, so which operations do you think are commutative?
Operations addition and multiplication.
Okay. All right. Jeremiah, why do you think subtraction and division are not commutative? And what did your table, I mean, it doesn't have to be just you can work with it.
I thought that adding and subtracting was associated because, oh wait, no.
It's okay. You're okay.
Adding multiplying and subtracting.
All right, but why is subtraction and division not commutative?
Because one makes another one bigger and one makes another one smaller.
Can someone give me an example of not commutative, Kenneth?
If you do 7 minus 3, you get 4. But if you do 3 minus 7, you get negative 4.
All right, Kenneth is exactly right. But this is where we have a cool little tool here. Remember that you can add a negative. So we can actually make this work. We can do 3 plus a negative 7 to get minus 4. So you can use this you can use this property of subtraction. It's okay. You have a question? No? All right. So does this make sense to everybody what I just did? All right. And then somebody have an example of a division problem to demonstrate that division is definitely not commutative. Fabius.
Let's see. If you were trying to divide 8 into 4 parts, you can't divide 4 into 8 parts and do the same thing.
Right. So because what's the value of these 2 fractions? Let's start with this. What's the value of this fraction?
4 divided by 8. Not exactly sure I didn't choose the problem.
That's okay. No worries. So what we can do here is we can do some cancellation. 4 cancels here. 8 is made up of 4 times 2. So 4 cancels. So we get 1/2 over here. Right?
Yeah.
So, all right. Taken. What over here, 8 divided by 4 equals what? So 2 is definitely not equal to 1/2. So that's an example of why division is not commutative. So I would encourage you to go ahead and write down that as an example of why division is not commutative at all. Go ahead and write that in your workbook, and I'll write down the subtraction example that Kenneth gave us. It was 7 minus 3, right? Okay. So go ahead and write down those examples in your workbook. And division and subtraction are not commutative, but we have that little trick with adding a negative. So let me write that up here. 7 plus a negative, oops, let's try that again.